day 3 of solving systems, and this is just kind of an add-on to day 2, some more practice with solving systems algebraically. So recall back to day 2. There were two ways that we could solve systems algebraically, right? There was, let me pull up the text. We could either use substitution, or we could have used elimination, right? And either way is fine. It doesn't matter which one we use. They're just two different methods that give us the same answer, okay? So elimination was we had to rearrange into standard form. We had to get ax plus by equals c. And then we eliminate one of the letters by adding the two systems together if they have the same value but opposite sign. So like negative 2x and positive 2x. So they would cancel out and I'd be left with just one letter y. Or we could have done substitution. That's where we get one of the letters by itself, x equals or y equals. And then once that happens, we can substitute it back into the system. And it's a little bit longer, but it's the same exact thing. And it doesn't matter which way we do it, okay? So let's go and solve this. Number one, with what method do we want to do? I'm probably going to end up doing substitution, okay? I'm going to get it in x equals or y equals form. And the reason I'm going to do that is because if I did elimination, it would be a real pain to try and get, I don't know, 2/3 x and negative 2/3 x or something, or 1/6 y and negative 1/6 y. It would be a real pain to try and cancel fractions out. So what I'm going to do is substitution, and I'm going to first off get rid of all these fractions in both systems. Before we even do the methods, let's take what we learned about simplifying fractions in equations and let's put that to work, okay? So let me pull up the pen here. Okay. So one thing I'm gonna teach you guys here is if we have all these different fractions, right? 2/3, 1/6, 1/2. Well, I want you guys to start multiplying by the biggest factor, I should say. Okay? 6 is a factor of 3, and 6 is also a factor of 2. Right? 2 times 3 gets me 6. 3 times 2 gets me 6. So I'm going to multiply all of these things by 6, okay? And I want to multiply all of these things by 6. So let's go ahead and do that. I'm going to multiply this by 6, this by 6, and this by 6, okay? Now, if you look here, I can do this one of two ways. I can see that 6 and 3, that would cancel out to 2, right? So if I was doing 6 divided by 3, it would be 2 left on the bottom. Or I could do 6 times 2 divided by 3. That's the way I like to do it. Okay, so I'm going to put this down here, and I'm going to do 12 over 3x. And then, well, this is like the same thing as 6 over 6, or this is easy because I can just cancel out the 6's. And then I'm left with plus 1y equals, and then if you see here, 6 divided by 2 is just 3, right? It's just 1 times 6 over 2. So I'm going to just leave that so I can simplify it all. So it's really just 6 over 2. And now I can do this division if I want to. I can do 12 over 3 is 4x plus y equals 6 over 2, which is 3. Right? So all I did was simplify this first equation, and I'm going to highlight that here so you guys can see what this piece became. This became this, and I got rid of all the fractions. This became this. And now let's do the same thing, but let's do it to the next equation. We're going to do it to this equation now. I want to get rid of all of these fractions. So I'm going to first erase this piece. Okay. Let's use a purple pen. So now, again, what is my highest number on the bottom? Well, it's 4, and 4 is a factor of 2, right? 2 times 2 is 4. So I want to multiply each of these by 4. So multiply by 4, multiply by 4, multiply by 4. Just like before. Okay, this is nice. 4's cancel out. Now I have 4 over 2. So it's just like saying 4 times 1 over 2. So let's start simplifying this. I have 3x. Okay, that's the 3x here. Then I have 4 times 1 over 2. Well, 4 times 1 is just 4. And then 4 divided by 2 is 2y. And then these 4's cancel out too, right? That cancels out. So I'm just left with 1. So we just took this whole thing, this whole system of fractions, and we made it into something much easier to look at, right? I have 4x plus y equals 3 now, and then I also have 3x plus 2y equals 1. Much easier to look at. So now, remember back to day 2, I said I was going to use substitution, right? So I want to get either x by itself or y by itself. Okay. Now, could we use elimination? Could I get it into ax plus by form, which both of them are? And I could, I don't know, maybe get 2y up here, negative 2y? Yeah, that's totally fine too. And maybe I should do both ways. I think actually that's a good idea. I will do substitution on this side, this left side. So I'm looking for text. So I'll type this out. I'll do substitution here. Substitution. And then I'll do elimination on this side for this one problem. Okay, so first let's focus on substitution here. So again, I want to try and get one of these letters by itself. It would probably be easier to get 4x plus y equals 3. It would be easier to get y by itself here because it's already, it doesn't have a coefficient attached to it. It's not 2y, it's not 3y, it's just y. And that makes life easy because I want to isolate this y now, okay? So what I'm going to do is I'm going to take this little arrow and I'm going to get y by itself, okay? So I'm going to do 4x plus y equals 3. Well, again, I'm trying to get y by itself, so let's subtract 4x from both sides. Subtract 4x, subtract 4x. Okay, this cancels out. I'm left with just y equals either negative 4x plus 3 or 3 minus 4x. You're going to get the same thing. Addition is commutative, so it doesn't matter which way I wrote this. So now I have y equals 3 minus 4x. Okay, that was my substitution method. And remember, substitution is just a little bit longer because now that I have y equals 3 minus 4x, I now need to substitute it back into these equations. Okay, so let's substitute it into the 3x plus 2y equals 1. Right, so I'm going to substitute in, let's use highlighter, let's use blue. I'm going to substitute in y equals 3 minus 4x, and I'm going to put it into this piece here. Okay, so it's going to be 3x plus 2 times y, and this piece is what is going in for y. Okay, so let's do that. I'm going to take this arrow, and let's see what this becomes. So I have 3x plus 2, and then y is 3 minus 4x, right? 3 minus 4x. So I'm going to substitute that in. 3 minus 4 times x equals 1. And then this is a simple linear equation. 3x plus, distribute here, 2 times 3 is 6. 2 times negative 4x is minus 8x equals 1. Now, combine our like terms. 3x minus 8x, that's negative 5x, plus 6 equals 1. Trying to get x by itself, so I'm going to subtract 6 to both sides. Subtract 6. 1 minus 6 is negative 5. So now this is one of those easy ones. I just got to divide by negative 5 on both sides. So x equals positive 1. Whoa, I'm going to rewrite that because that looks awful. X equals positive 1. Okay? And that's awesome. So now, how do I find y? Well, look, I already rearranged y here. I have y equals 3 minus 4x. I know what x is now. And so this makes life easy. I know, let's use, I don't know, yellow. I know that x is positive 1. So if I substitute in for x here, I can easily find what y is. So let's go ahead and do that. So I'm going to get, let's just put an arrow down here. So I have y equals 3 minus 4, and again, x is 1, so I'm multiplying by 1. So y equals 3 minus 4, so y equals negative 1. Okay? X equals 1, y equals negative 1. So that's my solution. My solution point, let's write this, is 1 comma negative 1. X, y. And again, we're not done yet. I still need to do my check. I gotta check both. So let's do check here. Remember how the check works. I need to check both equations with the solution that I found. Okay, so I'm going to use red here. No, not yellow. I don't want yellow. So, back into my equations. Could I put it back into this ugly looking system? Yeah, I could, but I already took the time and the liberty to get it into this form, right? I went from this to this, and also I went from this equation to this equation. So I wouldn't want to put my x and y back into this whole thing unless I had a calculator handy. That would be nice. But to make my life easier, let's just substitute it back into these equations. So the first one I'm checking is 4x plus y equals 3. So 4x plus y equals 3. And the other one that I'm checking is 3x plus 2y equals 1. So 3x plus 2y equals 1. So again, x is 1, y is negative 1. So 4 times x is 1, plus y, which is negative 1, so plus negative 1. Does that equal 3? Well, 4 times 1 is 1, plus negative 1 is the same thing as saying minus 1. And yeah, 4 minus 1 equals 3. It's a good check. Same thing over here. 3x, well again, x is just 1, so 3 times 1, plus 2 times y, well y is negative 1. Does this equal 1? Well, 3 times 1 is 3. 2 times negative 1 is negative 2. So 3 plus negative 2. And does that equal 1? It does. That's like saying 3 minus 2. 3 minus 2 is 1. Okay? So that's awesome. Elimination. Let's do the elimination method quick with the same exact thing. Remember, for elimination, I want to get into ax plus by equals c form. This is the form I want for elimination. So, if I look here, I still would want to get rid of all these fractions, right? Because it's in ax plus by form up here. It's just the fractions that we hate. So I'm going to take this piece here, 4x plus y equals 3, and 3x plus 2y equals 1, and I'm going to write that over here again. Because why wouldn't I? We went through the time to find out what this is equal to without fractions. So, we're going to have 4x plus y equals 3, and 3x plus 2y equals 1. Now remember this. With elimination, it needs to be in this form, and I want to have it so I have the same value but with a negative, right? And what I mean by that is same value but with the opposite sign, right? Same value, opposite sign. So which one will be easier to do? Well, probably the y's, right? It would be easier to get a negative 2y right here and keep the positive 2y, and that way they would just cancel out. So what am I going to want to multiply this top equation by? Hopefully you guys say I would want to multiply this whole thing by negative 2. So whatever I do to one piece, I got to do to every other piece. So times negative 2, times negative 2, times negative 2. So my new equation would be negative 8x plus negative 2y equals negative 6. So this turned into this. And I'm still left with the 3x plus 2y for this equation. I still have 3x plus 2y equals 1. Now, why did I do that? Think to yourself, why did I do that? What's going to happen if I now add these pieces together? What's going to happen here? Well, if I add these pieces together now, if I do negative 8x plus 3x, well, that's going to be negative 5x. And I have negative 2y plus 2y. Oh, okay, those cancel out. That's exactly what I needed. I need to cancel one of them out. And then I have negative 6 plus 1. Well, that's just negative 5. Okay, and then it's solving for x again. So I want to divide by negative 5 on both sides. So x equals positive 1. And if you look back down here, I did the same exact thing and I got x equals 1. So that's awesome. Okay? I got the same exact thing by just doing a different method. And then once I found x equals 1, I could substitute it back in to either this equation or this equation. And it doesn't matter. As long as I have x equals 1, I am going to figure out what y is. And if I did that work, I would still see that y is equal to negative 1. Doesn't matter if I plugged it into this equation or this equation. Okay, it does not matter. I'll get the same thing, and I still got to do my check. Okay, so that was both methods for number 1. I'm going to erase everything, so if you need anything, pause it now. And let's clear ink from page. And now one last problem that we'll do. If you want to try it by yourself, go ahead. I'm going to stick to one method here. So I have x minus 2/3 y equals 4, and 3/5 x plus y equals 15. Well, again, before I even choose my method, before I even choose substitution or elimination, I'm getting rid of my fractions. I don't like fractions. I just want to get rid of them. So for this top equation, my denominator is 3, so I want to multiply each piece by 3. Okay. What is this going to become? Well, 3 times x is 3x. These 3's are going to cancel out, and I'm just left with the 2y here. So minus 2y equals 12. Okay. Now same thing for this bottom piece. Get rid of that fraction. I'm going to multiply by the denominator, which is 5. So times 5 times 5 times 5. What am I going to get? Well, these 5's cancel out. I'm left with 3x plus 5y. 5 times 15 is 75. So I just turn this into this. Much easier to look at, right? Well, there's 2 ways I could go about this now. I could do substitution, where I get one of my x's or y's by myself, or by itself, or I could do elimination, which is where I want to cancel out one of my letters, either x or y. So think to yourself, which one would be more efficient? Which one would be easier to do in this case? I would say elimination would be easier to do, right? Because I have 3x and 3x. So if I want to cancel out the x's, if I added them right now, I would get 6x. That's not what I want. I want to cancel out the x's. So that tells me that I'm going to need to multiply, just like elimination says. Sometimes I have to multiply by one or both equations by a number to be able to do elimination. And that's exactly what this example entails. I'm going to have to multiply either this whole piece by -1 or this whole piece by -1, right? And it doesn't matter which one, because in both ways it's going to cancel out the x. So let's rewrite these over here. I have 3x minus 2y equals 12, and I have 3x plus 5y equals 75. So I'm just looking, and what I'm going to do is I'm going to multiply the top piece by -1. And if you see why, I'm just looking ahead. I'm going to multiply this top piece by -1 because this number is positive 75, and this will become -12. Okay? It doesn't matter. It really does not matter at all. Whatever you want to multiply by, whichever one you want to multiply -1 by is totally fine. If you want to go off course and multiply the bottom one by -1, go ahead. That's fine. You'll get the same thing. So, if I multiply this whole piece by -1, I'm going to have -3x. Well, now I have -1 times -2y. Well, negative times a negative is going to be positive 2y. Equals 12 times -1 is -12. And then this whole piece is staying, right? It's staying because I'm trying to cancel out my x's. So 3x plus 5y equals 75. Okay, so this whole thing turned into this thing. And then my last step is to add them together. Once I do that, my x's will cancel out. -3x plus 3x cancels out. And I have 7y equals 63. Solving for y, divide by 7 on both sides. So y is equal to 9. Okay? Now, if you guys noticed, starting off these problems takes a long time to get one of the letters that we want, right? That's where the most work and effort comes from. It's getting these letters, or just the first letter by itself, and figuring out what it is. But once we figure out one of the letters, life becomes so much easier. And I hope you agree with me. Life becomes much easier because once I figure out that y is equal to 9, I can just substitute it back into either this equation or this equation and easily find my x, right? So I'm going to substitute back into this equation. 3x minus 2y equals 12. Okay? And I'm going to put the y in. 9 in for y. So, when I do that, I'm going to do 3x minus 2y equals 12. So I'm going to bring that down here again. 3x equals 12. Again, I'm substituting in the y, the 9 for y here. Highlighter. I'm substituting this in for y. So, when I do that, I'm going to get 3x minus 2 times 9 equals 12. And then I got to simplify. I'm trying to get x. 3x minus 18 equals 12. Add 18 to both sides. Well, 12 plus 18 is 30. And then getting x by itself should see that x is equal to 10. Okay? So x is 10, y is 9. Now my solution is 10, 9, x, y. The last thing is the check. Don't forget the check every time we need to check. Okay? I know it's tedious, it's annoying, but it ensures that we did this correctly. Again, I'm checking both equations. So what are my equations? Well, again, I'm going to use these equations. 3x minus 2y equals 12. And I'm going to use 3x plus 5y equals 75. Let's substitute in our values. I know x is 10, y is 9. So for x, I'm going to plug in 10. For y, I'm going to plug in 9. 3 times 10 is 30. 2 times 9 is 18. Does 30 minus 18 give me 12? It does. That checks. Now over here, 3 times x, where x is 10, plus 5 times y, where y is 9. 3 times 10 is 30. 5 times 9 is 45. 30 plus 45 does equal 75. It checks out. Okay, and that is the end of